In this video, we're going to go over the Unit 10 test review. So first of all, for number 1, it says we're trying to find angle ABC, and that's down here, X. That's what this angle is right here. So what we need to do here is we need to first know that the angle is equal to the arc divided by 2. So we're given the angle here. We're given the arc here, so to find the angle ABC, we're going to take 168 and divide it by 2, and when we do that, that is 84 degrees. Number 2 says find angle WXY, XYZ, WZY, and ZWX. The first thing we need to realize here is for number 2, that opposite angles in an inscribed quadrilateral are supplementary. So opposite angles are supplementary. And that term supplementary means they add up to be 180 degrees. So I'm going to add X and Z together and set them equal to 180. Solve for X. So 2x plus 8 plus 5x plus 4 equals 180. When I add the 2x to the 5x, I get 7x. When I add the 8 to the 4, I get 12. I'm going to subtract 12 from both sides. When I do that, I get 7x equals 168. And when I divide 7 into 168, I get that x equals 24. So, and then we would plug that x back in to get our angle measures. So for angle WXY, I'm going to do 2 times 24 plus 8, that's 56 degrees. And for angle WZY, I'm going to do 5 times 24 plus 4, that's 124. And a great way to check this is to see that if when we add those two together they equal 180, and they do, then that means I got the right measures. So the next part of this problem is to solve for y. So again, we're talking about the opposite angles here. So we're talking about W. Sorry about that. We're talking about W and y. So we're going to add 4y plus 10 plus 6y and set that equal again to 180. That's going to give us 10y plus 10 equals 180. Going to subtract the 10 from both sides. That's going to give us 10y equals 170. Sorry, and y is equal to 17. Here again, we're going to plug the y back in to both those equations. So we're going to do angle XYZ is equal to 6 times 17. That's 102. And I know already that my other angle should equal 78 because that is what 102 subtracted from 180 is. So the other angle is ZWX, and that equals 4 times 17 plus 10, and that is, 78. I was going to put 68, but it's 68 plus 10, which is 78. So that is 78. So, those are all our angles, and again, those two added together do equal 180. So for 3, 4, and 5, first we need to define what a minor and major arc are and what a semicircle is. So minor arc is less than 180. A major arc is greater than 180. And a semicircle is equal to 180. So that means that if this is 180 over here, this is a semicircle. 225 is greater than 180, so this is a major arc. And 68 is less than 180, so this is a minor arc. So for number 6, the first thing I want to ask you is, what do you notice in the drawing? And what I notice is that we have 3 tick marks, which tell us that we have 3 congruent arcs. So if that's true, then the whole circle is 360. So we're going to take that 360 and divide it by 3. That's going to give us 120. Then I'm going to label these. So this is 120 here, this is 120, and this is 120. Now it's asking us for arc ACB. And remember, we have to do this in the order it's given. So we're going from A down here to C, up here to B. So I notice that when I do that, I get 120 twice. So 120 plus 120 is equal to 240 degrees. And that is our answer. We're going to go over here to number 7. This is asking us for two arcs, arc EA and arc EDC. Now the very first thing I notice is that there are percentages after the numbers, not degrees. So that tells me that this pie chart adds up to 100%, but I'm going to have to change those percentages to decimals, and then I'm going to have to multiply those decimals times 360 degrees, because that's going to then give me the arcs. So first we're looking at this one down here, EA. So arc EA is, it says 5%. So that's 5%. So we're going to change that into a decimal by dividing that by 100. So that gives us 0.05. Then we're going to take that 0.05, because we want arc EA in degrees. We're going to multiply 0.05 times 360. And when we do that, we get 18 degrees. Now we're going to do this similar thing for arc EDC. So arc EDC starts here, goes all the way up here. That includes both the 35 and the 10. So when we talk about arc EDC, we're talking about 35 plus 10. That's 45. Again, we're going to divide that by 100. That's going to give us 0.45. Multiply that by 360. When we multiply 0.45 times 360, we get 162 degrees. So this last problem. Now on this last problem, again, I see some tick marks. And that tells me that BC is 123 and AC is 123. So I'm going to put 123 over here too. And then in this problem, we're looking for arc AB. So we're looking for this arc up here. Well, that arc includes everything but those 123s. So I'm going to do 360 minus 123 plus 123. Well, 123 plus 123 is 246. So we're going to actually subtract the 246 from the 120 or from the 360, and that means arc BC, I'm sorry, AC, yeah, AB, my bad, arc AB is equal to 114 degrees. All right, down here on number 9. So on number 9, I notice that I have chord AB and chord AC are congruent. Well, if the chords are congruent, then their corresponding arcs are congruent. So that tells me that arc AB is congruent with arc AC. Now when I look at this one, I notice that I only have one measurement right now, and that's 78. So again, I'm going to take my 360 and I'm going to subtract 78 from that. When I subtract 78 from 360, I get 282. Now because arc AB and arc AC are congruent in their two parts, I'm going to divide that 282 by 2. When I do that, I get 141. So then I know that both of these arcs here, both this one's 141 and this one down here is 141. So it's asking me for arc AC, so arc AC is 141. We talk about number 10. I want to bring your attention to something first. So everybody look at the circle, and hopefully all of y'all can see that arc AC is half the circle. That means it's 180 degrees. So if I'm trying to find DC, then I would subtract the 24 from 180. So 180 minus 24, that equals 156. So we're going to put the 156 here. Then down here, same thing. We got half the circle down here as well. So again, we're going to do 180 if we're trying to find CB. 180 minus 56, and that's 124. Now that we have all the parts, and I like to solve for all the parts because we never know what they're going to ask us for. So now this asks us for arc A, and again, go in the order that the letters are given, A, D, all the way around here to B, ADB. So now honestly, there's several ways to do this. We could add 24 plus 56 plus 124. So we could do 24 plus 156 plus 124. Or we could take everything but this piece of the pie right here. So we could do 360 minus 56. That would also give us our answer. The third and final way is I notice that I have half the circle here. So I could also do 180 plus 124. No matter which way you choose this, your answer is going to be 304 degrees. So for this next set of problems, we're going to work through the drawing first, and then we will fill in the blanks. So a couple things I need to bring to y'all's attention. First of all, a central angle. Its vertex is at the center. And central angles equal our arcs. Then we have what's called an inscribed angle. In inscribed angles, vertex are on the circle. Now when we do inscribed angles, we're going to do the arc divided by 2. So that's what you need to keep in mind first. Central angles are equal to arcs and their vertex is at the center. Inscribed angles, vertex is on the circle and it's the arc divided by 2. So let's go ahead now and work through this drawing. So down here, notice we have this arc of 82 right here, and it maps to this angle up here, 82 degrees. So those are equal because, again, it's a central angle. I notice over here, similar thing. So we got 132 here. That means this angle right here is 132. Now I want to bring y'all's attention to the fact that we have half a circle here. So our arc right here, this arc, is, it says BD is a diameter, so that's 180 degrees. So to find this angle, find this arc right here, we're going to do 180 minus 82. That's 98 degrees, which means this central angle again right here is 98 degrees. Over here on the right, similar concept. So over here again, we're going half the circle. So for this part right here, again, we're going to do 180 minus 132, and that's 48. So that means if this out here is 48 degrees, then this right here is 48 degrees. Now we need to talk about these inscribed angles that are inside the circle and have a vertex on the circle. So we've got this one right here. This is an inscribed angle. Again, its vertex is on the circle right up there. And this is the arc that maps to it. So when we talk about this one, I'm going to go ahead and erase this definition up here. You also have room to show you what I'm talking about. So when we talk about this one, we're talking about taking this arc down here, which is 82, and dividing it by 2, because this is an inscribed angle. That would mean that this angle is 41 degrees. Then we got this one over here. So we've got, oops, come on thing, right, okay. It's not going to cooperate. Let's try a different color. Let's try red over here. Okay, so we're now talking about this angle right here. And again, the arc down here for it is 48. So this angle up here is going to be 48 divided by 2, which is 24 degrees. So now we have everything we need. So angle APB. So let me go ahead and erase all these lines I got in here, and I'll put the angles back on there. And then we can kind of answer the questions. So let's look at APB. APB is right here. APB right there. So that's 98 degrees. APD. APD right there. That's 82 degrees. Then we got ABP. So let's go ahead and pick up a different color here. So we got ABP right there. So that's our 41 degree angle. Then we got ABC. ABC, that means we're going to have to add, that's all of that right there. So we're going to have to add 41 to 64, and that's 65 degrees. Then we've got arc AB. So let's see if we can do this in blue. Arc AB right here. That is 98 degrees. Then we've got arc BDA. So again, we start with B, go to D, and around to A. So we started here and we ended there. So we're going to add 132 to 48 to 82, or 180 plus 82, either way. So that's going to be 262 degrees. Our last two, arc BAD. So let me do this in another color. B, down here to A, over here to D. And that looks to me like it's half the circle. It is. So that's 180 degrees. And our last one is arc DC. So arc DC is right here, from here to here, and that one was 48 degrees. So what you need to keep in mind here is that inscribed angles, vertex is on the circle, central angles, vertex is in the center of the circle, and inscribed angles are half the arc that's intercepted, whereas central angles are equal to the arc. So for number 19, first thing we need to notice is that we need to see these words, area of a sector, because that's going to tell us what formula we need. When we look on our formula sheet, it tells us that this is pi r squared theta over 360. Now we know that r here is equal to 12 and that theta is equal to 60 degrees. So we're going to go ahead and put those in here. So we've got pi 12 squared times 60 over 360. Now remember, if it asks you for the answer both ways, then you're going to leave pi in one answer, and then you're going to multiply by pi. So when I multiply 12 times 12, that's 144 times 60, and I divide that by 360, I get 24. So my first answer is going to be 24 pi, and that's going to be centimeters squared. And then when I multiply that by pi, I get 75.4, again, centimeters squared. So on this next problem, again, we're looking for key words here, and I noticed that the words arc length are there. So that formula is 2 pi r theta over 360. Again, r equals 7, and this time it says of a semicircle, so our theta is equal to 180. So we're going to do 2 times 180 times r. Wait, let me do that again. Let's do this in the order it's given. So we're going to do, I'm going to leave pi for last. So 2 times 7 times 180 divided by 360. And again, I'm going to put that pi on last. So we're going to do 2 times 7 times 180 divided by 360. That gives me 7 pi, and this is meters, not meters squared because it's a length. And when I multiply 7 times pi, I get 21.99, again, meters. All right, so down here for 21, when we do this problem, we need to find the area of the sector, and then we're going to subtract from it the area of the triangle. So let's see what that looks like. So we've got pi r squared theta over 360 minus base times height divided by 2. So when we start to work this problem, let's go ahead and do this over here. So our r, so we're going to have 3 squared times 90, theta is 90, divided by 360. And we are going to multiply that by pi this time, because we're going to need to get that as an actual measurement. And when we talk about our base and our height, notice over here that all radii in a right triangle, or in all radii in a circle, are the same. So our base and our height are going to be, sorry, we're going to subtract that, minus 3 times 3 divided by 2. Okay, so when we multiply out the area of the sector, we get 7.07. When we do 3 times 3, that's 9, divided by 2, that's 4.5. So we're going to subtract from that 4.5. And so our answer is going to be 2.57, and that's going to be inches squared. Again, because it's an area. Okay, so when we do these problems, what I told my students is just change the pi to 180. So you're going to substitute 180 for pi. So what we're going to do here is 2 times 180 divided by 3. And when we do that, we get 120 degrees. Here we're going to do 4 times 180 divided by 5. When we do that, we get 144 degrees. And here we're going to do 180 divided by 2. That's 90 degrees. So that's how we convert from degrees, or from radians to degrees. Now, when we talk about going from degrees to radians, we're going to divide by 180. And when we do that, we're going to get a decimal. We're going to change the decimal to a fraction. And to do that, we're going to do math 1, enter on our calculator. Once we do that, we're going to then put pi on in the numerator. So let me show you. So we're going to do 210 divided by 180, and then we're going to put pi up there in the numerator. So when I do that, and I entered it in the calculator, and I pushed math in 1, I got 7 over 6. Now it's going to be 7 pi over 6, because we're going to put, again, pi in the numerator. When I do the negative 65, when I do that, I get 0.36. So again, divide this by 180. When I do that, I get 0.36. Change that by math 1. Actually, negative 0.36. Then when I change it, I get negative 13 over 36. And again, that's going to be 13 pi over 36. Over here, again, divide by 180. When I do that, I get 0.69. When I push math in 1, that becomes 31 pi over 45. That's how we represent these problems in radians. So the first thing I notice when I read number 24 is find the value of x if the measure of AB, arc AB, is 59 degrees and the measure of arc CD is 47 degrees. So I'm going to label these parts. So this one's 47 right here, and this one's 59 over here. So what I know is that to find that angle in the middle, that angle x, x is equal to arc plus arc divided by 2. So that means to find x, I'm going to do 59 plus 47 and divide that by 2. So when I add 59 to 47, I get 106. When I divide 106 by 2, I get 53 degrees. Number 25 says find the measure of angle 1. So on this one, I see that I have 2 tangents. Now, this problem, the way we set this up, whether it's 2 tangents, 2 secants, or a tangent and secant, are all the same. So our formula to find the angle is outside arc minus inside arc. And this is logical because the outside arc is bigger than the inside arc, and it's always going to be bigger. We're going to divide that by 2. So let's go ahead and what I realize right here in this problem is that we don't have the inside arc right now. We don't have this arc right here. So we have to find that. Now the whole circle is 360. So we're going to do 360 minus 245. And that's going to give us 115. So I'm going to go ahead and label this right here 115. Now we have the inside arc and the outside arc. So we're going to do 245 minus 115, and we're going to divide whatever that number is by 2. So when I subtract 115 from 245, I get 130. And when I divide 130 by 2, it tells me then that my angle measure for 1 is 65 degrees. Okay, so number 26 over here. So there's a couple ways I could do this problem. I could solve for angle 2 right here first. Now we notice that this arc right here is 125 degrees, and that's a line right there. So that angle right here, this angle right here, is going to be half of the 125. So I could find it that way. So that's 62.5. So the measure of angle 2 is equal to 62.5. Now there's two ways I could solve for angle 1. Now I could subtract that 62.5. So I could do 180 minus 62.5 because that's a straight line. So that means the measure of angle 1 would be equal to 117.5. Now the other way I could do it is I could subtract this 125 right here from 360 to get this part over here. So if I subtract 360 minus 125, that gives me 235 out here. Now if I divide that 235 by 2, that's what gives me 117.5.